Here we are, we're working on the second semester final for intermediate algebra, and we're going to take a few videos here. This is page 1, questions 1 through 14. The first question that we're going to be doing is to substitute in x equals 4 and y equals 32 into the equation and simplify that. And we're going to do the exponent first, so I get 4 times 16 plus 64 plus 0, and simplifying that I get 128. Question number 2. We're going to be putting some like terms together, and I get 3x squared minus 2x squared gives me 1x squared. We don't need to write the 1. And 4y minus 5y gives me negative y. Question number 3. We need to do our distributing first, so I get negative 3x squared plus 6 minus 4x squared plus 2. Putting those like terms together, I get negative 7x squared plus 7. Question number 4. We need to put our like term a's on the left side and the numbers on the right side, so I'm going to subtract a from both sides first, giving me a plus 2/3 equals negative 1/3. Subtracting 2/3 from both sides, I get a equals negative 3/3, which is the same as a equals negative 1. For question number 5, I'm going to distribute the 1.5. I'm going to get 3x plus 3 equals 6, 3x equals 3, and x equals 1. Question number 6, let's distribute first. 2x plus 4 equals 4x minus 4 plus 4. The plus 4 and minus 4 on this side, they go away. Subtracting 2x from both sides leaves me with 2x equals 4, so x must be equal to 2. Question number 7, the absolute value. We need to split it into 2, so I'm going to have one where it's positive, and we're going to do the other one where it's negative. Simplifying, I get x equals 5, and negative x minus 2 equals 7, so I'm going to add 2, negative x equals 9, so x equals negative 9. So we have two answers, x equals 5 or x equals negative 9. For question number 8, we need to do the same thing, so I'm going to split it into the 2, and negative 2x plus 1 equals 7. Simplifying over here, subtracting 1 from both sides, I get 2x equals 6, y equals 3. On this one, if I distribute, I get negative 2y minus 1 equals 7, negative 2y equals 8, so y equals negative 4. Question number 9. I want to solve it for y, so I'm going to subtract x from both sides. I get y equals negative x minus 2. Here I'm going to do the same thing, subtracting x from both sides. I get negative y equals negative x plus 2. We want y by itself, so I'm going to multiply the whole thing by negative 1, which is going to give me y equals x minus 2. Question number 11, I'm going to distribute my 3. 3x plus 3y equals 4. Subtract 3x from both sides. I'm going to get 3y equals 4 minus 3x. Dividing by 3, dividing by 3. I get y is equal to 4 minus 3x all over 3. We can't simplify these 3's because you'd have to be able to divide it also into the 4. Question number 12. I'm going to solve this and then graph it. So I'm going to subtract 3 from both sides. 3x is greater than or equal to 9. X is greater than or equal to 3. On my graph, here's 0, here's 3. greater than or equal to is a bracket heading to the right. Question number 13. Going to add x to both sides. And I get 4 is less than 3x plus 1. Minusing 1 from both sides gives me 3 is less than 3x, so I'm going to get 1 is less than x. I want to rewrite that because I'm used to having the x on the left, and I'm going to have x is greater than 1, parenthesis heading to the right. In number 14, we have a compound inequality, so I'm going to subtract 1 from all three parts, and I get negative 3 is less than or equal to x is less than or equal to 4. On my graph, I'm going to have negative 3, there's 0, and there's 4. X is greater than or equal to negative 3, so I'm going to bracket that heading that way. X is less than or equal to 4, bracket that heading that way.